Ignition sequence start.
Good morning. You're looking at Mission Control Houston, the International Space Station's flight control room, and the Orbit 2 team of flight controllers. They are one of 3 teams of specialists who every day take the shift to keep track of the operation of space station systems and help the station's crew members as they pursue their agenda of scientific research and station maintenance. Expedition 63 Commander Chris Cassidy and his 2 Russian crewmates are finishing up their first full work week together as a crew of 3. They're getting set to receive a Russian cargo ship after having taken the best seats off of the planet to observe Earth on the 50th anniversary of Earth Day.
Welcome to Space to Ground. I'm Leah Cheshire. This week, the crew on the space station witnessed Earth Day from the best seat in the solar system. On April 22nd, we observed the 50th anniversary of Earth Day. The world marked the first Earth Day in 1970, and this year, many of us participated from home. As we looked out our windows at our home planet, 3 people living on the space station had the same opportunity, but from 250 miles above. Listen in as NASA astronaut Chris Cassidy, who is on his 3rd spaceflight, talks about Earth Day from the International Space Station.
I'm really thinking about how Earth is a spaceship for all of us, and whether it's a pandemic or climate impacts, we need to take care of it. Like Anatoly, Ivan, and myself, we're taking care of the International Space Station right now. Just like all of the people on Earth need to do their job, do their part to keep Earth healthy.
The space station has seen a lot of traffic recently, and there's no sign of that slowing down anytime soon. On Friday, April 24th at 9:51 p.m. Eastern Time, the Progress 75 spacecraft is scheduled to launch from the Baikonur Cosmodrome in Kazakhstan, arriving just a few hours later at 1:12 a.m. Eastern Time. This Russian resupply craft will deliver about 2.78 tons of food, fuel, and other supplies, and will remain at the station until early December. We're looking forward to May 27th and NASA's SpaceX DM-2 commercial crew mission, the first launch of astronauts from American soil since conclusion of the Space Shuttle program in 2011. Join us live at 11 a.m. Eastern Time on May 1st for a trio of news briefings, during which you can learn more about the mission and its crew. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The DM-2 mission Leah mentioned, which is now targeted to launch on May 27th, will be the first in NASA's commercial crew program to carry astronauts to space, and in this case, up to the International Space Station, where Bob Behnken and Doug Hurley will join the Expedition 63 crew. Here are 2 more of our commercial crew astronauts to guide us through the program that will resume the launch of astronauts to space from right here in the USA.
NASA's commercial crew program is ready for launch. Did you know the last time we launched astronauts from America was in 2011?
NASA is working with companies Boeing and SpaceX to take astronauts to the International Space Station from America once again. Let's look at how this will happen.
Look at the spacecraft on top of the rocket. This is where humans will be sitting. The astronauts will be buckled into a spacecraft, stacked on top of the rocket as it is launched into space. The rocket holds all of the fuel needed to get to space.
It takes a lot of energy to lift the rocket off the ground, with gravity constantly pulling it down, which is why most of the rocket is filled with fuel. During the rocket's climb to space, it will increase in speed, which means its energy will also increase. Once the rocket has made it past Earth's atmosphere, the engine will finally cut off. The rocket and the spacecraft will separate, and the astronauts will make their way toward the station, where they will be working on science experiments and engineering projects.
What do you think will happen when the spacecraft travels back to Earth?
Boeing has made the Starliner CST-100 to keep astronauts safe as they travel to and from the station. It's designed to touch down safely on land in the western United States. The Skyliner has parachutes it will use as it prepares for landing, but will also have large airbags expanding under the spacecraft to cushion the landing for the astronauts before stopping completely.
SpaceX's Crew Dragon was also created to send astronauts to and from the space station. As the spacecraft comes back to Earth, the outside will experience temperatures over 3,000 degrees Fahrenheit. The Crew Dragon has been designed to keep the astronauts inside comfortable during the ride home to Earth. Once they are back in the atmosphere, the spacecraft will release 4 main parachutes to slow down the speed and energy of the vehicle before it splashes down in the Atlantic Ocean or Gulf of Mexico. These spacecraft are exciting sneak peeks at the future of space travel.
And NASA's Commercial Crew Program.
Want to know more about space travel? Check out this website for more information.
The Commercial Crew Program is dedicated to developing the spacecraft that will carry astronauts to the International Space Station, where crews are conducting scientific research that they can't do on Earth and learning the things we need to know to support future missions out of low Earth orbit and to the Moon in just a few years.
50 years ago, we went to the Moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the Moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go. We go as the Artemis generation.
We go.
The coming missions of the Artemis program are being built with help from the International Space Station program, from what we're learning there about long-duration spaceflight, so we can better protect the human crew members on those future missions. In the more than 19 straight years that we've had people on this space station, those crew members have supported hundreds and hundreds of science experiments that have taken advantage of the microgravity environment. Just before astronaut Christina Cook returned to Earth earlier this year, she talked about some of her research highlights from a mission that ran almost 47 full weeks.
First and foremost, our responsibility is to our crew up here to keep each other safe. Secondly, I would say our responsibilities are the work, the amazing work that we do as part of this orbiting laboratory. As a microgravity laboratory, we do science in all kinds of different arenas, from physical science to biological science, human research, technology demonstrations, and many more. So doing that work and carrying out the work that is the purpose of the International Space Station is definitely one of our responsibilities. And I also think that we have a responsibility to the people that we represent up here, to carry people's dreams into space with us, to communicate the perspective that we have up here.
Copy that. I'll step through on my own for the setup and let you know when questions come up. And yes, we definitely are all doing this as a we and as a team. So you all will be installing the test cartridge as well.
We have a series of tasks that we're asked to do, and we know that it's going towards a good cause, that it's benefiting the Earth, and that it's advancing the cause of exploration for all humanity. So being able to participate in that every single day is such an honor, and I'll definitely miss that. The microgravity environment is a lot of fun. It brings about a lot of interesting changes in the human body, and obviously it enables the amazing science that we do here. When I think back about the legacy of this mission, I think the thing that I'll be most proud of is just bringing my best every day and contributing and giving back to this program that has allowed me to be here, has allowed me to work for, a mission that I've believed in for my whole life, to my training teams, to the teams on the ground, the engineers, the planners, and the flight controllers that make everything possible. And like I said, just remaining vigilant in meeting the challenges every day up here, and just remembering that it's all about giving back and contributing.
For future missions, like going back to the moon by 2024 and then out into the solar system, biomining could offer a way for crews to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do here, and that might affect the output from extraterrestrial biomining. So, there's an investigation on the International Space Station studying how microbes grow on and how they alter planetary rocks in microgravity and in simulated Martian gravity.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
Along with doing hands-on science in the International Space Station's laboratories, the crew members have been talking directly with students on the ground to share the experience, and some of them have been making fun instructional videos in zero-G. In this installment of the STEMonstration series, astronaut Scott Tingle demonstrates the orbit of Spacecraft and offers the viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft, orbiting Earth like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
By virtue of being 250 miles above the Earth and from orbiting over different parts of the planet every day, the International Space Station provides a handy spot from which to gather data for a number of experiments that are designed to learn about the home planet of their creators. On the occasion of the 50th anniversary of Earth Day, here's a look at a number of those experiments, including the ones that involve astronauts with cameras in their hands.
Earth's climate is the product of many rich and complex systems. It's affected by water in its many forms, on land, in the air, in the oceans, and as ice. It feels influences from vegetation, from soil conditions, from the carbon cycle, from human impacts. We study and observe our planet's ever-changing conditions in many ways, from many locations. One location in particular provides a unique and powerful vantage point, allowing us to see our planet in high detail and on a broad scale: space. The International Space Station is home to many instruments that help with the study of our planet in a variety of ways. Each is an amazing resource for scientists and researchers, but together, they paint a picture of Earth richer and more detailed than any one instrument could provide. From the vantage point of the orbiting laboratory, JEDI measures Earth's surface vegetation, producing 3D views of forest height and structure and the surface topography beneath. Forests and other plant life respond to a variety of environmental stresses, and the EcoStress instrument allows researchers to study plant temperature and provides insights into how life on Earth responds to changes in water availability. OCO3 measures atmospheric CO2 with high accuracy, helping researchers better understand CO2 increases and decreases and the impacts of those changes. And through the use of two cutting-edge spectral imagers on the station, HISWI and DESIS, researchers have access to highly detailed information on materials across Earth's surface, from identifying minerals and rock types to distinguishing between plant species. There's another and often overlooked observational instrument on board the space station: crew members equipped with digital cameras. Over 3 million images have been collected by astronauts from the station, and those images can be put to a variety of uses. William Stefanov is branch chief for the Exploration Science Office, a part of the Exploration Integration and Science Directorate at Johnson Space Center. He says handheld cameras used by the crew act as a complement to the data gathered by the station's various instruments. And that comes down to the ability of the crew to take pictures that are panoramic and oblique versus a straight-down look. That panoramic view can be quite useful when observing natural disasters as they occur, such as wildfires or volcanic eruptions. Stefanov explains, a camera is an excellent tool for examining the plumes created by wildfires or volcanoes, because it gives you an immediate three-dimensional picture of what the plume looks like, what its structure is, and how far it's extending. The observational instruments aboard the space station provide science capabilities that are more than the sum of their parts. These instruments, along with photography from crew members, serve to keep a multifunctional eye on the condition of our home planet. For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more eye-opening information about space exploration, visit science.nasa.gov.
A few minutes ago, we heard International Space Station Commander Chris Cassidy talk about Earth Day from the vantage point of having a better view of the planet that is the center of attention than does anyone who is on the planet. What he didn't mention is that NASA has a history of combining the science of studying Earth from orbit with art that grabs our attention. In recognition of the 50th anniversary of Earth Day, here's a moment with the artist who created the 2020 NASA Earth Day poster to explain her inspiration.
Hi, my name is Jenny Motter, and I'm the art director for NASA Science. For many years, I've been creating the Earth Day posters for NASA, and each year I try to focus on a new perspective, whether it's the 2017 total solar eclipse, the Earth as the shore of the cosmic ocean, or discovering our roots in the depths of astrobiology. I attempt to illustrate our home, our place in the universe, from the unique vantage of NASA. This year, being the 50th anniversary of Earth Day, I wanted to do something really special. But first, I'm going to talk about my inspiration. Last year, I read a book about trees that really inspired me. We see trees all around us every day, but I never imagined how much we have in common. For instance, if you hold a stethoscope to the trunk of a hardwood tree, you can hear its heartbeat as water and nutrients move through its system. And most astonishing is the relationship that trees have with fungi. Tree roots attach to fungi underground, which not only allow them access to more water and nutrients, but enable them to communicate with each other for miles. In 2018, Swiss scientists discovered voltage-based signals in these networks, similar to our nervous system. These signals allowed trees to send warnings of drought, disease, or insect attacks to neighboring trees. It's really quite amazing. So, this was all very inspiring, but how could I relate it to NASA's unique perspective? I was talking to a colleague one day, and he said, "A river delta looks a lot like a tree from space." And that was the light bulb for me. From there, I started doing more research and found this great metaphor by James Hutton, the father of modern geology. He described Earth as a superorganism, comparing the water cycle to the human circulatory system. Basically, the heart pumping blood through our veins. This brought it full circle for me. A tree as a river delta with the Earth's metaphorical heart pumping water through its natural circulation system. 3 metaphors in one composition. So, back to wanting to do something really special. Since it's the 50th anniversary, I wanted to try something that I'd never done before, to paint the Earth Day poster. I've been a painter since I was a kid, and it's what led me to study art and design in college. I began by drawing the delta tree on a 15 by 30 inch piece of watercolor paper. I found a bunch of satellite images and started to paint, mostly making up details as I went along. The final artwork made for an interesting illustration, but for me, something was missing. The make it up as I go approach didn't quite capture the NASA aspect that I'd hoped for. So I went back to the digital drawing board and started compositing the detail with actual real science data. Another first for me. I mostly pulled imagery from the Landsat series of missions, which NASA operates in conjunction with the United States Geological Survey. My main resource for the delta was taken from my all-time favorite Earth is Art image, the Lena Delta in Siberia. But a variety of other images were also used in the composition, from a desert in Southern California to the lakes of Western Mongolia to the very tip of South America. Imagery from all over the world adds detail to this composited illustration. Can you find these images along with the hidden animals in the river delta? To download the 2020 Earth Day poster, along with these activities and posters from past years, visit science.nasa.gov. Thanks for listening, and remember that we are all part of the superorganism that is Earth.
You know, for all the years that men and women have flown in space, they've taken pictures out the window of their home planet. Now, those pictures are amazing, remarkable, astounding, to be sure. But for the folks who took the pictures, it's still something of a strain to convey to us Earthlings just how miraculous that view really is.
When you look out into the depths of space, you realize just the vast ocean of darkness, and we're on this little island.
Without a doubt, when you are climbing on your rocket, when you're launching into space, when the engine cuts out and you get to look back at Earth, absolutely every sacrifice is worth it. Every dream is worth it. The entire road there is worth it. Every bit of it is worth it.
It almost, I dare say, grieved me to think about how in the world am I going to describe this?
I will never forget that sight. The thin blue line of the atmosphere, the curve of the horizon. That's when it became real, really at a gut level. I'm actually in space.
All life is connected on this planet, and everything I do is in one way or another going to affect someone else that I share this planet with, or some other creature that I share this planet with.
The most significant realization to me was looking out and realizing not how far I was from Earth, but how close I was to Earth and how connected I was to Earth.
I'd give a lot to see that view again.
If you'd like to get another look at any of the stories we showed you today, you can do it by checking us out on YouTube or Facebook. There are the addresses. Be sure to look around too, because there is lots of cool stuff that you can find about NASA and America's human spaceflight program. Now, if you're going to be out bumping around the interwebs anyway, check out Houston, We Have a Podcast. It's where we've talked to folks about their works in many aspects of space exploration. And we post new episodes every Friday, most weeks, but this week we posted on Wednesday for Earth Day. And it's a special interview with Will Stefanoff, who was cited in the ScienceCast feature you just saw. He's talking about the Earth observation experiments on the space station and the value of what we learned from there, on top of the awesome pictures that we all get to enjoy. Go to nasa.gov/podcasts for this week's episode. That's also where you can find all our previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.